Hello everyone, welcome to today's performance engineering session with Hands-on. In this session, we will be discussing about application saturation point. For any given application, the relation between throughput and number of users will be something like this. So as we increase the number of users, throughput also increases. At certain stage, the throughput becomes stagnant. So after certain stage, that is called as saturation point, even if we increase the number of users, throughput will not be increased. So this point is called as saturation point, and also this is the point where we get maximum throughput. If we further increase the number of users, there are chances that throughput may also get degraded. Okay, this is the theory. This is the theory about how throughput and the number of users are uh, interlinked. And here assumption is we don't have any constraints on the hardware resources like CPU, memory, network, IO, or any JDBC connections or HTTP connections and so on and so forth. Okay, so we will have a sufficient, assuming here we assume that we have sufficient resources, and this is purely a saturation point for the code and sequels. Okay, so let us, this is theory, and let us try to understand a little bit in detail. So here we take one API, okay, and let us assume that we have an application which has only one API, and we'll try to find what is the saturation point for that application. And also let us go to the code and see that how a saturation point has occurred at whatever level we have seen during the execution. Okay, so this is the get slots API, and we have only one API, as I said, that is get three available slots. And let us conduct the test and see where exactly is the saturation point. Okay, so okay, one user. Okay, so this is one user and 1.9 TPS. Okay, one user and TPS we have got is the 1.9 second, and there are no errors. So let us stop the test. And let us repeat the test with 5 users and see what is the TPS we get. So now we are testing with 5 users. Yeah, this TPS is around 2 TPS. Okay, for 5 users, the TPS we got is 2 TPS. Okay, it means it is doing 2 transactions in a second. That is the throughput. Yeah, okay. Okay. See, one user 1.9 TPS, for 5 users 2 TPS. It means we increased a number of users from 1.5, and throughput also increased from 1.9 to 2 TPS. Okay, let us test with maybe 15 TPS or 10 users. Sorry. For 10 users, again, TPS is 2 only. Okay, again, it is 2 TPS. Looks like we have got the saturation point. Okay, let us test with 20 users. 20 users. Yeah, how to TPS is again 2. Okay, maybe we can stop at this point of time. If you see here, so we have got 1.9 TPS for the users 1, and we increased the number of users from 1 to 5. TPS remained same. Looks like this is the saturation point, and this is also we can call it as the optimal throughput. Okay, after we increased the number of users from 5 to 10 or 10 to 20, throughput has not increased. So looks like this is the saturation point, that is 2 TPS. Okay, so now the point is, as I said, uh, as we identified the saturation point, that is 2 TPS, but let us go a little bit details into the code to see why exactly we are got only 2 TPS, why the 2 PS as limited to 2, why it is not more than 2. That we will see. So as we know, for any given application, uh, given applications, there are two uh, types of code snippet, I can say, two types of code snippets. So one code snippet can be executed in parallel. So other part of the code snippet cannot be executed in parallel. It will be executed one after another. For example, if you see here, so these lines of code can be executed in parallel. Okay. So for example, if you are executing this API, okay, with 10 users, so these lines of code can be executed by 10 threads in parallel. Suppose if you execute this code with one user, if response time is overall response time is 1 second, so with one user, we get 1 TPS. With 10 users, we get 10 TPS. And 100 users, we supposed to get 100 TPS, because these lines of code can be executed in parallel. So whenever we have a code which can be executed in parallel, the TPS or throughput proportionate will be proportional to the number of users. But when we have a code, so which cannot be executed in parallel. For example, if you see this code, so this code cannot be executed in parallel. The moment control comes to here, it always been single threaded. Okay, so since this code snippet is part of this API, which we are testing right now. Okay, so overall overall performance of this particular API is completely determined by the processing time of this particular code, because these are always single threaded. Let us assume, not assume, we have seen when we tested this API with a single thread, we saw that it took around 520 milliseconds. Okay, here 20 millisecond maybe for this particular piece of code, because we have a few lines of code, so which can be executed in parallel, and this can be executed by single thread at any point of time. So overall, it took around 520 milliseconds, and this code alone took around 500 milliseconds. So irrespective of number of users, irrespective of number of users, the overall TPS will be determined by this piece of code, and this always been single threaded. For example, here you see it is 500 milliseconds, right? Means uh, we can have 2 TPS. That means we can execute 2 transactions in a second. If the processing time of this piece of code is 100 milliseconds, then it will be 10 TPS. Okay, so that's how it works. So was in the real world applications, you will have these lines of code at multiple places, and the cumulative processing time of all the code snippets for a given application determines what is the saturation point. Okay, so I hope this is clear. For example, if you have a code snippet, okay, so if it takes, let us say, 10 100 millisecond, okay, So 100 millisecond. So then in a second, it can execute 10 transactions or 10 iterations. It means it is 10 PPS. Okay. So in summary, uh, in summary, uh, in summary, the overall saturation point of a given application will be determined by the code written under contention area. Okay, so that is the point. Yeah, thank you very much. So thank you very much for watching this video.